We're going to be talking about VTP version 3. That's number 1 in our discussion today as part of this program. It's not going to be a long discussion, but I think it's important because you're definitely going to have to be aware of the differences. Hey, Tim, welcome aboard. You're definitely going to have to be aware of the differences between version 2 and version 3. And most likely on the CCIE lab, you're going to be required to configure VTP version 3. And what I also decided to do in this evening session is, even though it's not on the list of topics for switching, I've decided to go ahead and add a discussion about private VLANs. You'll certainly be tested on private VLANs on the written exam, but you may not necessarily have to know private VLANs for the lab. I'm not sure. It seems like it could be a topic. It certainly wouldn't be a core topic, but it might be an ancillary topic that you might have to know for the lab. But definitely private VLANs is something that you're going to have to know for the written exam. And it's probably something that you guys are not really that familiar with. This is actually, these two topics might be some of the first couple of topics that we discuss where you may not have as much background or understanding in. So I think they're going to be good topics for us to talk about tonight. I know it is Friday night. It's the night to relax and kick back from your long work week. So I'm going to try and make it as concise as possible, but also as informative as possible. All right. As always, we're going to be using our 4-switch topology here. Tim, I want to thank you for stepping up as a mentor in this group yourself and helping Ken out. I know you spent quite a bit of time working with Ken to get his GNS3 up and running. So, man, I really appreciate that. And that's really what this group is all about, right? Everybody kind of helping each other out and making sure that we can all succeed. So, and incidentally, Ken, Tim raved about you. He said you were an awesome guy. So that's a good thing too. All right.
Tim's the man. He's very knowledgeable. I found that out.
Yeah, Tim is a jack of all trades and a master of some. He's definitely he definitely has been around the block a few times. So anyway, let's go ahead and get started. Like I said, we're going to be covering VTP version 3 today. We'll be setting it up in our switches here and talk about why VTP version 3 is necessary. That'll be the first video. We'll stop that video and then we'll go into recording our second video, which is our private VLAN discussion. And we'll throw together some example configurations or sample configurations of private VLANs as well and take a look at how we can verify those and configure them and so on. All right. When it comes to obviously managing an enterprise, obviously VTP is one of those protocols that kind of pops its head up every once in a while as a protocol that can provide us the opportunity to exchange VLAN information. And we talked in the last lesson about VTP version 1 and version 2 and some of the distinctions between those protocols and spent quite a bit of time actually talking about really just some of the differences between version 1 and version 2. But really in a modern enterprise, VTP version 3 is really where you're going to want to be, right? It is a much more secure implementation of VTP, but it also has a whole bunch of different benefits that provide us a lot of it has a bunch of benefits, and we'll talk about what those additional benefits are as part of this discussion here. We obviously look at configuring our network with VTP for the purposes of being able to propagate VLAN information across multiple switches so that we can make sure that we're not making mistakes in VLAN numbering and VLAN names, kind of eliminating all of the possibilities of having any kind of problems with our topology based on that. Later on, we're going to be talking about spanning tree. That's going to be a topic that we'll be covering next week. And we'll talk about things like multiple spanning tree. where VLAN optimization gets extended into this multiple spanning tree concept. Well, VTP version 3 is a very important component of that. All right. We want to be able to propagate VLAN information and so on. VTP version 3 provides not only the flexibility that version 1 and 2 does, but it allows us the ability to incorporate the extended VLAN range in the VTP configuration. It also allows us to incorporate a lot of security components. And so let's talk a little about some of the differences, the key differences that we would see with VTP version 1 and 2, and then talk a little bit about what VTP version 3 does, right? So this new version of VTP, much more administrative control. Hopefully I'll be able to demonstrate that to you guys today. If you guys want to pull up the topology on your computer as well and participate, I would definitely suggest that as we go through the configurations. That way, if you have any questions, you can share your screen, pose questions, and so on. The VTP has always been one of those protocols that we've kind of wanted to use in the network, but we've been scared to use it, or we've kind of stayed away from using it because of its security vulnerabilities, right? The ability for somebody to join a domain and overwrite, or the potential of overwriting the database, is pretty significant. So some of the functionality of VTP version 3 eliminates those concerns. The two most beneficial enhancements that you're going to see, and this is why I think it's probably going to be something that would be covered within the CCIE lab, is this concept of extended VLAN support, right? So we have all the ISL VLANs, the traditional or the original ISL VLANs, VLANs 1 through 1001, but this new version of VTP allows us to support 802.1q VLANs all the way up to 4095. So we can propagate that information and populate that information through VTP version 3. Also, and this is part of our the second part of our discussion, is it provides us the ability to transfer information regarding private VLAN structures. Community VLANs, isolated VLANs, and whatnot. And finally, the most improved component, I think personally, of VTP is the support for databases other than VLAN databases. So VTP version 3 has support for multiple spanning tree as well. Okay? We know it's a layer 2 protocol. We talked about that when we talked about VTP version 1 and 2. And we also know that the overall goal of VTP is to simplify and reduce the possibility, simplify the configurations of our VLANs, and then also to reduce any kind of unintended configuration errors that might occur in the configuration. VTP is traditionally going to be used, obviously, to propagate all of our VLAN information. So when we add a VLAN, or we suspend a VLAN, or activate a VLAN, anything that we do is going to get propagated, like even just changing a name of a VLAN and so on. VTP is obviously still a Cisco proprietary protocol. Even VTP version 3 is also proprietary. So you're not going to be able to see this kind of functionality in a lot of the environments that are non-Cisco specific. All right. Now let's take a look at where we were the last time. Let me pull up my command line here, and we'll take a look at some of the configurations. Looks like Ryan sent a chat message. Hold on one second. No? Okay. I thought he did. All right. So I'll just do a quick show of VTP status. Obviously, the very first thing that you're going to want to do is you're going to want to be able to identify whether or not you're even running VTP, or you're capable of running VTP version 3. And we can see with this particular switch model, we do have the capability of running VTP version 3. Now, my suggestion, because we can transition from version 1 and version 2 directly into version 3, would be that to make sure that you have your version 1 or version 2 configurations completed, and verify the operation of version 1 and version 2 before you migrate into VTP version 3. Because at least you know you have the fundamental functionality configured that you need to be able to run VTP version 3. All right, now as far as the domain goes, obviously the VTP domain, that's the distribution area where all this automatic configuration gets propagated. The propagation occurs only over trunk links. So if I do a show interface trunk, I want to make sure that I have active trunk links, which it might be something that you run into on the exam where you may be missing some trunk links or whatnot. So I want to, of course, do a show interface trunk to be able to identify whether or not I'm doing the appropriate trunking. Doesn't look like we had some configurations saved from the last time, but we'll go ahead and switch over to .1Q in a little bit. GNS3 and these particular switches, these IOL images, love to negotiate to ISL for some reason. All right. Now, as far as the flow of VTP information, obviously VTP version 3 is going to use the exact same concept of domains like we saw in version 1 and version 2. Only the devices belonging to the same domain are going to be able to process the information that's being sent through VTP. So if for some reason I have switches that are not a member of my domain or switches that are a member of a different domain, just like with VTP version 1 and version 2, they're not going to be able to process that VLAN information. All right, so the first couple of things that we need to do is we're going to have to configure, obviously, version 3. Actually, before I do that, let me go ahead and switch my encapsulation method back to .1Q. Interface range Ethernet 00-1, Ethernet 10-1, Ethernet 20-1. And switch port trunk encapsulation .1Q, switch port mode trunk. And that's switch 1. Let me go over to switch 2. Incidentally, guys, have you guys had a chance to even try to load up this switch config? So in this particular case, if I do a show VTP status, obviously we already have a domain set. Unfortunately, I don't have the ability to reset that domain. I could do a delete flash : VLAN.dat. It won't work in GNS3, but because we don't really have a flash drive, it's all virtual. But on a real router, I could delete flash : VLAN.dat, and that would delete my VTP configuration. And then I would reload the device and I'd have my null domain and my default configuration. We talked about this in the last class, the last session. In previous versions, any switch that had that default domain of null would basically take whatever very first received VTP message it got, and it would configure the domain name on itself to match that particular switch, unless there was a password configured. Obviously, with authentication, we wouldn't be able to synchronize unless we had the appropriate authentication. This is one of the security differences that now exists in VTP version 3. The domain has to be manually configured no matter what. Even if the domain is null, the domain has to be manually configured. So before you enable VTP version 3, you need to verify if the domain name is set to a non-default value. And if it hasn't been done, you need to go ahead and set the domain name and configure it. What's going to end up happening is that if I come into my switch and I go in here and I say VTP version 3, it'll take the command now, but if I had a null domain, it would not allow VTP version 3 to be set. I would have to set the domain name first. All right. Now, the other part of this is the concept of spanning tree and how this relates to VTP. We're not going to get into the spanning tree discussion until next week, but later on, when we go back and do the spanning tree discussion, I'm going to talk to you about what are the impacts of spanning tree when we're working with VTP, especially VTP version 3. All right. So obviously we're going to use VTP version 3. We don't have to set the domain name, but we could do VTP domain and CCIE underscore v3. All right. Obviously, we would want to go ahead and establish VTP version 3 on all of our switches. And VTP domain CCIE underscore 3. Same thing on this switch here. VTP version 3, VTP domain, CCIE underscore 3. And one more time. Config T. Obviously, we're getting an error on this. We didn't see the error on the other switches. Actually, this is a pretty good point, right? Trunk negotiation does rely on VTP configurations to be concise. We can see here that DTP, which is the dynamic trunking protocol, is complaining about doing trunk negotiation because the VTP domain doesn't match. So even though VTP is not directly related to trunk configurations, it is something that you need to be aware of, that it can, having issues with the domain configuration can affect VTP operations as well. All right, VTP version 3, I don't remember if I did that command or not, so let's go ahead and put that in. All right. So we changed the domain name. The domain name can be any number of characters. I'm not quite sure what the specific length is, but it can be any, I think it's up to 32 characters in length. All right. All right. Now, if I go ahead and run a show VTP status, we're going to see that the output is slightly different than what we saw with traditional VTP. We still have some of the common pieces to it. In fact, let me go back to this switch, I think. So here was our original output for show VTP status. We still had kind of the same pieces. But then when you look under feature VLAN, it's a little bit different, right? So you've got the domain name, we're running version 3, traps generation are disabled, enabled with pruning. This is the device ID, which we can see from show version. The base MAC address is, this is GNS3, it's not going to show us that. Show version would show you that base MAC address, which would allow you to, this base MAC address is being derived from the base MAC address of the switch itself. But now we can see here the maximum number of VLANs that are supported locally are 4,096. And we also see these values here: primary description, primary ID, configuration revision number, of course, didn't change. So we're seeing some additional pieces to this configuration that didn't exist prior to what we did with VTP version 1 and 2. All right. Now with VTP version 1, we were limited to only 1,000 VLANs. And there was a very kind of tight coupling, if you will, of the VLAN implementation, pruning, and VTP. And by combining those three pieces together, we were able to implement stuff kind of more efficiently. The other aspect of VTP version 1 was, and version 2, of course, was the support of Ethernet and Token Ring and FDDI, Fiber Data Distributed Interfaces. And the goal, of course, was to ensure consistency across VLAN names, across the domain, and so on. VTP version 1 was enhanced. It didn't support Token Ring. We talked about that in the last lesson as well. So VTP version 2. There were some other enhancements in VTP version 2 as well, but the primary enhancement was the support for Token Ring. The the functional base in VTP version 3 is pretty much hasn't changed. So backwards compatibility is actually built into the protocol. You can have one switch running version 3. You could have other switches running version 2. All right. Uh-oh, what happened there? Spanning tree received a 1Q packet on a non-trunk, a .1Q BPDU on a non-trunk, Ethernet 1.0 and VLAN 1. What switch am I on? Switch 4? Let's see what that's all about. Switch 401, so it's saying that that's a non-trunk. Let's go check switch 1 real quick. Do show interface trunk. 1011, 2021. Oh, they're all trunking. That's kind of weird. That it threw that error. Blocking 00, inconsistent port type. Get to do some real live troubleshooting. So it's kind of freaking out a little bit about these two links right here, but I'm guessing that has to do with spanning tree, and spanning tree is blocking a couple of ports there. It's causing us to see some errors. We'll troubleshoot that in a little bit. Okay. All right. So again, the basic functionality of VTP version 3, the core elements to VTP version 3 are pretty much the same as version 2. So we have complete backwards compatibility. And it is also possible, I've seen this before in some configurations on a peer link basis, to discover VTP version 2 devices, even though I might be running a VTP version 3 domain. All right. So we have a very secure environment with VTP version 3, support for structured VLANs like private VLANs or PVLAN configuration. Like I said, up to 4,000 VLANs. Actually, it's more like 4,096. And then we also can create, and I'll see if I can demonstrate this a little bit later on, the support for a single database or single VTP instance, but then having the ability to add additional VTP databases or instances, much like we see with multiple spanning tree. In fact, that's kind of where that discussion comes from, is the idea that with multiple spanning tree we have different instances of spanning tree topologies. There's also protection built in for the unintended database overrides that we could see with VTP version 1 and 2, where you might plug in a switch that's joined to the domain, or was already a member of the domain but was disconnected at some time or another, may end up having a higher revision number than some of the other switches in the topology. So one of the ways that we deal with that is to ensure that we have passwords and we run transparent mode. Well, in VTP version 3, we actually have protection mechanisms built in that protect against that unintended overwrite of the database itself. We also have options for clear text or hidden password protection. I'll show you that later on. Per port base instead of a global scheme. VTP version 1 and version 2 is always a global configuration. And then we also have better resource handling and kind of a much more efficient way of transmitting and receiving the information. The biggest thing that you guys are probably going to have to know for the lab, of course, is how do I configure not the basic VTP operations, because you already know how to do that. Domain name, password, VTP version, and such. That's all pretty much the same configuration. But when we get into the authentication, setting up the instances of VTP, that's going to be a little bit more involved. All right? Excuse me. With version 3, there's this concept now, and I've seen this, I saw this in a few questions on the written test, of transferring something called an opaque database. So let's say, for example, I have a VTP version 1 and version 2 that are interacting with my VLANs and the VLAN process directly. If we can offer a reliable and efficient transport mechanism for that database, we can actually expand the overall function of VTP beyond just managing the VLAN environment. And VTP version 3 allows for the support for mapping multiple spanning tree databases. Right now we're running per VLAN spanning tree. We'll talk about running rapid spanning tree and so on. But I actually have the ability to create different types of instances when we create a multiple spanning tree domain. I don't know, do any of you guys run MST in your environments today? Most likely not. It's mostly probably per VLAN, rapid per VLAN spanning tree. But you're definitely going to be tested on the concept of multiple spanning tree, not only on the written exam, but in the lab as well. So that's going to be a discussion that we'll have when we get into the spanning tree section. All right. Now, when it comes to the VTP instance, we can have the VLAN database with VTP version 3. Actually, the VLAN database exists really kind of in any version of VTP. But with VTP version 3, we actually have the ability to have the VLAN database and the MST database, or we have a third database called an unknown database. This is called VTP mode, and we'll talk about that as we get into the configurations a little bit later on in this lessons. MST, the multiple spanning tree protocol, does support between 1 and 64 different instances or mappings between the VLANs themselves and calculations. Let me explain a little bit about how that works. Since I've mentioned it a couple of times, I'll just do a quick little sketch here to give you guys an idea of what multiple spanning tree is, since we've mentioned it a few times. So traditionally, if I have a topology, standard kind of campus design topology, I might have my distribution layer switches connected to my access layer switches, and then I'll have some sort of bonded link between those two switches. We'll talk about that in one of the future lessons. And let's say that I have 100 VLANs, okay? And I've decided that I want to do a little bit of load sharing over the network by distinguishing 50 VLANs on one side of the link, 50 VLANs on the other side of the link. So if I do 1 to 50 and maybe 51 to 100 on this side, that's great. That allows me the ability to take all of my VLAN 1 through 50 traffic and send it that way, and all my VLAN 51 through 100 traffic and send it that way. The inherent problem with this design, though, is that we're now running 100 instances of spanning tree. Spanning tree can be a very, very chatty protocol because we're sending out BPDUs on every interface per VLAN for this spanning tree process for every 2 seconds, actually. So as the number of VLANs increase, so does the amount of traffic. All right. So in the case of multiple spanning tree, what we do is we take our VLANs and with MST, so we're going to go to an MST domain, we will create an instance for those VLANs. And I might do the same thing on the other side. Let's go with brown. So I'll take these VLANs and I'll put them into an instance by themselves. All right. And then rather than running spanning tree on a per VLAN basis, there's a default instance as well. That's going to be instance 0. All right. That's instance 0 is the one that gets used whenever we don't have anything assigned to a specific instance that we've created explicitly. All right. So instead of running multiple, over 100 implementations of the spanning tree topology, we run spanning tree per instance. So we've got a spanning tree instance for this group, STP1, and we've got a spanning tree instance for this group, STP2. Which means that we're drastically reducing the amount of BPDUs that are being sent across the network, and spanning tree operates more efficiently that way. Because VTP tends to run based on a VLAN configuration and based on a per VLAN configuration, multiple spanning tree, when we're working with VTP version 1 and version 2, doesn't really sync up very well. My point is that VTP version 3 integrates with this MST database and the VLAN database much more seamlessly. We'll take a look at that as part of the configuration as well. All right. As far as the unknown database, we've got the VLAN database in the case of VTP version 3. We've got the MST database. That unknown database is really just reserved for future features and future use. So it doesn't really have a function right now. All right. The concept of using and comparing the configuration revision number, like we talked about with version 1 and 2, that concept still exists. If I get a VTP version that is higher, I will synchronize to that revision number. And the concept of incrementing the revision number hasn't changed in VTP version 3 either. The revision number basically represents the timeliness of an update that's going to be included as part of the VTP message. Any device that's going to receive a message is going to compare its own number to the received number that it got. All right, and you guys know this already. If the received number is larger than whatever I have on my local database, we're going to request a remote database update from the uplink switch or from one of the servers in the topology, and then that local database is going to be replaced by the remote database. All right. In VTP version 3, in VTP version 2 and version 1, not only did servers have the ability to send out updates that could override a database, even clients had that ability. In VTP version 3, only a specific device within the domain, which is called the primary server, is allowed to update other devices. So we protect this, the possibility of having an inadvertent rewrite by establishing a primary server within my VTP domain. All right. And obviously the whole point is that we're trying to get rid of the possibility of some sort of unintended automatic configuration change by adding some switch to the network later on down the road. All right. And we'll take a look at that configuration a little bit later on. The configuration revision number works the same. So we can do a show VTP status. We can see the configuration revision number. You'll notice in my topology here, because I haven't really configured any of the settings, if I do a show VTP status, I don't really see a primary server presently configured in this topology. We would see that listed, and by the way, here's those two options that I mentioned: unknown, feature MST, feature VLAN. Since we're not running MST, we're not going to see any functionality built in here, but these were the different databases that I was referring to with regard to the ability to exchange information. This is something that you wouldn't have seen in VTP version 1 or 2. Okay. Let's see. What else do I want to talk about before we get into some of the configurations? We still have, in VTP version 3, we still have client, we still have server, and we have transparent. But now we also have another role that exists in VTP version 3 called off. It's not really tied to a physical device, but it's tied to the instance or maybe a mode for VTP operations. And that instance can be either a VLAN instance or an MST instance. So we do have the ability of establishing that role in the spanning tree, the VTP topology of off. And I'll show you guys how that works a little bit later on. Just like VTP version 1 and 2, any switch that's operating in transparent mode is going to use a local permanent storage space to hold the database, primarily the content of the NVRAM, right? Startup config or running config. Transparent mode switches don't send or receive VTP advertisements. Any received VTP message is going to be relayed out of whatever trunk ports exist, except for the port that the instance came in on, and so on. All right. We don't do any domain checks in in VTP version 3, but that's fine. We didn't do that even in version 1. In client mode, any kind of device that's configured as client mode only uses a temporary storage space locally to hold any of the VTP information that it receives. So remember, if you've got a client mode switch configured in your topology and you reboot that client switch, it's not going to have a VLAN.dat to refer to. It's not going to have any VLAN configuration that it can refer to. So it's going to have to go out and get its configuration from the primary server or from some other server in the topology. Okay. Off, let's talk a little bit about the off mode, because that wasn't something that we had seen previously. This was introduced fairly recently, actually, this off mode. And it was intended to be very similar to transparent mode, but the difference between transparent mode and off is the termination of any VTP messages that I receive rather than the relaying of those VTP messages. In off mode, we can configure this globally, or we can configure it on a per interface basis. So we may have a situation where we have maybe logically, or at least from a business perspective, 2 different VTP domains. We don't want any cross-pollination of information. We will set that mode to off for those links that go over to those layer 2 domains. All right? All right. And let's go, we're going to start with switch number 1. We've already seen some of the basic configurations, show VTP status. We can see that we're running version 3 now. We did that on all of our switches, set the version to version 3. Default is version 1, of course. We still have the ability to set the mode to client, server, or transparent, or we can set the mode to off. And we can also even specify the, I don't know if GNS3 supports this. Let me see if it supports this real quick. Config T, VTP interface. Yeah, it does. Okay. We can specify the interface name used by the VTP updater in the device as well. I'm going to show you guys that a little bit later on. We just put in the name of the interface that's providing the updater ID for this particular device. We'll talk about that configuration a little bit later on. Now, we had in the past the ability to type in VTP password. And if I type in a VTP password Cisco, I could do a show VTP password, and it would tell me that VTP password. Not only was it not encrypted, but it was something that we could actually see just by simply typing in the VTP password command. Password does not propagate as part of VTP, but it's something that you would have to configure on all the devices. So we have the ability of doing a couple of different things with VTP version 3. We can specify that the password is hidden. So the password is actually not going to be saved in clear text in the VLAN.dat file. Instead, it's going to be a hexadecimal secret key that's generated from the password when it gets saved. So if I do, for example, VTP password Cisco hidden, we set the device password, but now if I do a show VTP password, we can see that the password output is an obfuscated password. I'm not sure if that's I'm very curious if that's a level. I don't believe this is a level 7 password. No, it's definitely not a level 7 password because I recognize the Cisco string. So that hides the password, but we also have another option. We can actually use the secret option as well. Or we can enter the password using the secret option. So let's say that this was the password that I set on this particular switch. I can copy that information and I can come into this switch and I can say VTP password, put in the text, and then put in secret to indicate that that is the password that I'm setting on that switch. I'm basically copying that from one of the other switches in my topology, and I'm pasting it in this switch so that it can join that VTP domain secretly, right? That's basically like putting in a copying the username password with the word secret, or copying a enable secret password from one router to the other. Okay. Obviously, one of the recommended practices is to go ahead and set that password. I'll just go ahead and do that on all my devices here because I want to make sure that we can synchronize later on. VTP password secret. Now I could have done VTP password Cisco hidden. And if I do a show VTP password, do show VTP password, you can see that the ciphertext is the same, right? From what we had posted previously. So it's not that this is a salted value, or it's like an enable secret password where we have some sort of salted value. It's just to obfuscate the password so that somebody, if they get a hold of my VLAN.dat file, they can't identify what the password is specifically. Okay? All right. Now, there is a command that we can use to establish what our primary server is going to be in the topology. Remember, the primary server is the only device in the topology that has the ability of overriding the database. But before we get into that configuration, well, actually, let me talk a little bit about, before I show you the actual configuration, because this is something that's completely new and unique to VTP version 3. Only one server in the domain can be promoted to be that primary server. The clients or the secondary servers are going to receive their configuration from that primary server. The secondary servers themselves, they're going to store any of the configurations that they have in their NVRAM, and then the clients themselves will store them into DRAM. All right. When we were talking about VTP version 1 and version 2, a server can be configured through the command line by just typing in the command VTP server. In fact, let me show you that command. Right? So I can still come in here and I can do VTP mode, and I still have the option of selecting client, server, or transparent. So let's set this guy to server. All right. And let's go ahead and do the same thing on this guy, VTP mode server. And you'll notice that it's given me kind of a different output than what I would have seen with VTP version 1. In VTP version 1 or 2, it would have just simply said, I'm changing the mode from client to server, or I'm changing the mode from server to client, or whatever it is that I'm actually typing. But you'll notice here it says, actually let me go to switch 4. It says setting the device to VTP server mode for VLANs. What it's referring to there is, if I do a show VTP status, it's talking about all the VLANs, and it's talking about the VLAN feature. We haven't done anything with multiple spanning tree, and unknown is never going to be used because that's for future use. So we're modifying essentially the basic configuration for VTP version 3 just for the VLAN feature, not multiple spanning tree. I don't know if I'll talk about the MST piece. I might show you a couple of MST things, but without actually getting into an MST configuration, it's not really going to do us a whole lot of good to take a look at that. All right, if I want to promote a server to be a primary server for VLANs or for MST, I can do the command VTP primary. So let's say I want switch 1 in my topology to be the primary server for my VLAN operation. I just simply say VTP primary, should be VTP primary. That's weird. Should be VTP primary VLAN. That's usually the command that I use. That's weird. Here. There we go. All right, so it's trying to go out there and it's trying to find or identify if there are any conflicting servers. So we're changing the operational state of a secondary server in our topology to the primary server. So what's going to happen is the switch, it usually doesn't take that long, but what's going to happen is the switch is going to go ahead and advertise all of the information across the entire VTP domain. If we have a hidden password like we do, we're going to be prompted to put in the password. If we didn't have a hidden password, it wouldn't have asked us for the password, but since we're using a hidden password, it did. But before this particular device can actually take over the role of the primary server, it has to go out and discover all of the other servers in the domain to see if there's any kind of conflict from maybe another server being a primary server or whatever it might be. If I have conflicting servers, if those are discovered, then I have to reconfirm the takeover operation. And then what's going to happen is it's going to say, okay, you absolutely want to do the takeover? That's fine. We'll go ahead and apply the takeover as well. All right. Now, another option is to specify a feature. Let me see if we have that option here with this version of iOS. VLAN feature. And we just have force, yeah. So force means that essentially you're going to force the server to take over as the primary, regardless of whether or not there's a conflict in the VTP domain. Sometimes you'll have an option of feature, so you would see a feature here. That really depends on the specific operating system, but that would allow you to change the. Actually, you know what? It is here. I just thought of that, but it's not. We don't use the feature keyword. All right. You can see that we can force this server to be the primary for the MST feature or the VLAN feature. Some of the iOS requires you to use the feature keyword before you enter that command, but the feature allows me to identify whether it's going to be multiple spanning tree or VLAN, or if I can force the configuration without any conflicting devices. So I just simply override. Notice it gives me the option to do just a carriage return here. If I was to hit the carriage return here, it would actually default to the VLAN database rather than the MST database. So if I do primary, put in my password again, it's now going out and doing the conflict check again and trying to identify whether or not there are any conflicts. Eventually it will come back and say no, and I'll act as the primary server. Okay, hit return. Now if I do VTP primary force, VTP primary force, try that again. Notice that it didn't actually go out and check for any conflicts in the configuration. So let's do a show VTP status. And you can see now that the VTP operating mode, which was previously, if I do a show VTP status here, is just a standard server mode. This device is now acting as the primary server. So this might be something that they ask you to do in the CCIE lab with regard to the configuration. They might say, you know, let's go ahead and make sure that VTP is configured, and then on top of that, let's make sure that that switch whatever in the topology is the only switch that can act as, or that can overwrite the database within the VLAN. It might be a very simple task, a basic task, but if we hadn't talked about VTP version 3, it might be something that you aren't familiar with. All right. Another command that's kind of useful, that I think is kind of useful, is to do a show VTP counters. That can give you an idea of how many kind of VTP messages, configuration changes, version, mode, revision number, any kind of advertisement statistics. Those are going to be displayed here. All right. If you see, for example, a lot of summary advertisements, that means that there may be some instability in the VTP domain. You can also do a show VTP interface to see which interfaces are running VTP, We do have the capability of enabling or disabling VTP on a per interface basis based on VTP version 3. We'll talk about that a little bit later on. All right. Show VTP password we already looked at. I'll do it one more time. Show VTP password. All right. Now, let's see what happens here. This is my primary server, switch 1. Let me see what happens if I go into switch 4. Quick, do a show VLAN. So you got VLANs 50, 60, and 70. Let me try and add VLAN 100. And notice it says VTP VLAN configuration is not allowed when the device is not the primary server for the VLAN database. I've always wondered about this. Maybe you guys can offer some insight on this, but traditionally with VTP version 1 and 2, it's like, okay, well, this is a server, which means it can overwrite the databases. So now it's, what is the difference between a server and a client? I can't delete a VLAN. I can't add a VLAN, right? I can't even go into VLAN configuration mode. If I type config T, for example, and type VLAN 50, doesn't even allow me to go in and configure a VLAN that already exists in the database. So the primary function trumps all of the other configurations or all the other traditional VTP configurations that we have, which is an interesting concept. All right. There's another VTP command that you can run. It's called show VTP devices. And this is obviously unique to VTP version 3. It's going to give you all of the information about the neighboring switches that exist within the VTP domain. And obviously they would have to be within the domain. All right. The information is learned through the process of exchanging information. Curious why we're not seeing any devices here, but we'll take a look at that. You know, we should be seeing some devices. Let me do a show VTP status. Primary server, VLAN 7, primary description switch 1. Interesting. So it should be there. Let me see if I generate a VLAN, if that propagates some information. Config T, VLAN 100, name test. Let me go over to switch 4. Show VLAN. Interesting. Show VTP status. Huh. Let me try one other configuration here. No VTP password. And let me take off the password here. I'm wondering if there's an issue with our authentication. All right. Now let's try and configure a VLAN again. Huh, that's weird.
Did you try to make switch 1 and 4 the primary server?
No, I don't think so. I think I only...
Looks like 4 was the server as well.
Well, it is a server, but it's not the primary. I thought switch 1 was the primary. That's okay, that's a server. That's a server. Try this again. Maybe because I removed the password, it lost its primary status. Oops. Yeah, now it's a primary server again. Mike sent a message. Let me see what Mike said here. VTP doesn't live in the config, just in VLAN.dat. It depends on what mode you're operating in. So if I do a show run here, we can see that all right, I'll answer that next question in a second. So we can see that we don't really have any configuration, VTP configuration listed here. Now, if I'd say VTP mode transparent, all right, if I do a show run, all of the VLAN information is going to get copied over to the running config. So we can see here that the domain is set now. Any VLANs that I have configured will show up in the running config. So only in transparent mode do we store everything in the running config. Otherwise, everything is going to be stored in VLAN.dat. Now, what doesn't get stored in VLAN.dat are the interface-specific configurations. Those are going to be stored as part of the running config. So making an interface a trunk, assigning a VLAN to an interface, that kind of thing is not going to be stored in VLAN.dat. And you need to do a show VTP password to see the password configured. Yes. Now, if it's hidden, it's going to have that hash, but a show VTP password will show you the password. All right, so let me change this guy back to server mode, VTP mode server. Make sure it's still primary, show VTP status. Yeah, it seems like, I didn't notice this before, like show VTP status won't mention the password is set. Correct, that is correct. You will only know if a password is set if you run the show VTP password command, which is actually a good point because on the lab, especially the troubleshooting section, you might have an issue with VLANs propagating in your configuration. Well, guess what? Show VTP password will indicate whether or not they might be saying, well, I'm trying to create a VLAN on this switch and it's not propagating to this switch. Why is that the case? And you might have a password mismatch. The other thing to make sure you pay attention to is this hash, because the hash should match on all the devices in the domain, given that the domain name and the password is set correctly. So it looks like in this behavior that the switch is losing its primary status every time we kind of make a change to that, major change to that database. So let's do VTP primary force again. All right. So now config T VLAN 1000 name test2. Curious why it's not propagating. It should be propagating to the rest of the switches in the domain. See, we're getting a configuration revision number of 0. There is a debug. You'd see something else. VTP. Why is it? Let me see. Debug. I guess there isn't a VTP debug. I thought there was. So we had obviously a little bit of issue with the domain name not matching. I had paused the recording to save myself embarrassment when you guys watch this a little bit later on. But we were able to identify here in our debugs that we were dropping a packet because we were not in the same domain. And I had meant to put V3 on all of them, but I ended up putting VTP or CCIE 3 on each one rather than VTP version 3. So these are the switches that are members of the domain. We can see whether or not there's a configuration revision mismatch, which feature we're running. We'll show you the MST feature a little bit later on. This is the primary server. This is the local device ID. of the device that's a member of the domain, and then the switch description is just simply the host name of the device itself. Okay? All right. I guess that's it. There's really not a whole lot else about VTP version 3. We do the MD5 digest. I showed you guys that with the VTP password. Now you could do service password encryption. If you just did, say for example, config-t, VTP password, Cisco, all right, and I can still do a show VTP password. I could do service password encryption, and it should, the command still shows the password, but I believe in the VLAN.dat file, no, it should show as encrypted. Let me see here. Or not encrypted, but obfuscated. Yeah, it's not doing it. Normally this would be hidden, but it wouldn't be hidden in a way that it's hashed like an MD5 hash. So it's still, it would have the kind of the VTP, the level 5 or level 7 hash that we all know is not secure. So the hidden option is the best option. And in the case of service password encryption, the password would still show up in the VLAN.dat file. It would just be hidden in the show VTP password output. I don't know why it's not doing it here, but I'm not even going to bother with that. If you use the VTP password hidden option, config-t, VTP password, Cisco hidden, not only does it hide it here, the show VTP password, but it will also hide it in the VLAN.dat. So if somebody gets a copy of your VLAN.dat, they're not going to be able to see that the password. All right. If you want to apply the password like I showed you guys before, you just use the secret option to cut and paste it. You would have to put the secret word after the ciphertext. Mike asked a question: any way to see the VLAN.dat file from the switch, or is it encrypted? That is a great question. Unfortunately, with GNS3, I don't think, well, I know I can't do it because there's no flash in GNS3, but you might be able to do a more // VLAN.dat. Usually when you do a more / VLAN.dat, actually, you know what? Let's test that theory. With respect to VTP version 3, there